We're at the LA Robotics meeting, and we have a lot of people here. We have a lot of cool robots that are brought in for fun stuff. I don't know what they all do, but let's take a look at some of the equipment. Funky stuff. But now, then, somebody bought a lot of little robots.
Recharge off the USB port.
Toy store.
I built a text-to-speech chip inside there, and then this pickup. Really strong, well-made wheels. Probably the best value in robotics right now is these $60 Vex wheels.
Oh, those are Vex?
Yeah.
Oh, okay.
Yeah.
Great.
The main bad thing about them is the way they're designed. They have just a little tiny square shaft in the middle, like a 1/16.
Yeah.
It's really kind of designed to hook up to their particular servos and axles, and it's not very strong at all.
So it bends?
Yeah, that bends. So in order to hook them up to some pretty beefy motors, we just, like I said, we just kind of rapid prototype the hubs, and they actually kind of fit in between the spokes of the wheel inside there. But a couple other interesting things is these little motor controllers here. These are like $4 on eBay. Yeah. Right. They're getting like really cheap. Yeah. L298.
L298.
L298N.
Wow.
So I just slammed this thing together. I had a this is a basic stamp board, not the final controller at all, but it's what I had kind of laying around, just kind of get a demo going. Even these lithium-ion batteries. These are getting cheap, like $2 a piece now.
Wow.
These are 24-volt motors, but I'm using about 30 volts here. Each one of these cells is about 4 volts fully charged. Here's 16 volts and 60, so about 32 volts. But you might lose about 2 volts going to the controller, so about 30 volts per motor.
Okay. And it's to go over rough terrain?
Not really so much rough terrain. It's really designed best for nice, smooth, flat things. But if you Google, here's another thing to search. AirTrax Cobra is a forklift made using these wheels, right? So you can imagine a forklift maneuvering inside a warehouse could use this, nice alignment ability to kind of pick up pallets, very accurately and kind of stuff.
And they don't need that much turning.
Text to speech. What's your name?
Trish Soyasu.
Trish?
Now you programmed the chip in there?
No,
That comes that way.
Let's get it to say Soyasu.
Well, funny you should ask. Well, this is one of the articles I wrote on this chip. I found this guy he presented this chip.
Hey, not bad, robot.
Serial data. So I just 3 or $4.
Amplified speaker. Sorry.
It's got a rechargeable battery inside. Recharges off your USB port, right?
Okay,
so
USB.
It's basically a self-contained amplified speaker. You can plug it into your iPod or whatever, or something like that.
Okay.
Play the music out loud. But I hacked into that.
Hacked into it.
Built the circuit like literally in. It's inside there, right?
What book are we looking at? Page 46 of
Servo.
Servo Magazine, November 2012. Okay.
Yeah. So I just built the guy's text-to-speech chip inside there.
Oh, so they actually showed you that you could hack into this.
Well, this is my article.
This is your article.
Yeah.
Oh, what's your name? Eric Ostendorf. Okay, cool. And then is this layout described in here?
Pretty much just that right there.
Okay.
Then I provide examples how you can send data through basic stamp, pickaxe, and Arduino. Right.
Basic stamp, pickaxe,
for everybody.
Great. And this is the pickaxe controller,
Output from a computer.
electronic components, programming interface
How sophisticated is it?
the keyboard.
What screen readers they have now in the computer?
Transparent to me, so it just works.
Around the house.
So it's an instructable.
Yeah.
Oh, this guy?
So go ahead.
Which one?
This one.
Okay. Let me.
Man, you've got a lot of.
I got it all going on here.
Yeah. This is Robot Magazine. What issue?
This is November, December 2012.
November, December 2012. Okay, open it up.
Yeah, so this guy starred in, this is one of the articles, I wrote a 4-part article using the pickaxe processor. And this particular one, it's just sort of a test bed. This one has a variety of sensors. There's ultrasonic sensors, infrared sensors for range finding.
Okay.
It's also got twin, actually one of my sensors fell. This one can navigate, it can track to an infrared beacon by using 2 different infrared sensors like that. So when on my YouTube channel, I have like 3 different beacons set up. It'll just kind of navigate in between them all day long.
This is a sensor here?
Yes, this is one of his. Yeah, one's missing right there. Right.
And tell me about the dial. What were you saying about the dial?
The dial. This I use 3 touch sensors right here. These pennies are just big. They're just big. Actually, there's a piece of tape over it, so you're not even really touching it. But it's a capacitive sensing thing. Pickaxe M2 series can. M2 series. Yeah, it can have I think 8 or 10 different touch sensors. So I just have a program. If you sort of move your finger in a circle over the 3 pennies, it knows that you're traveling in a clockwise direction. It can also detect counterclockwise.
I see.
So one of the programs, as you rotate, it'll make the robot follow along and kind of accelerate and decelerate like
that. And what is this here?
That's just the voltage regulator. Just one of the necessary evils. Okay. But again, it's just a little test bed. I have my little text-to-speech chip can plug on right there. So it's just basically a rolling experiment platform for the 20M2.
Cool. Nice.
Okay.
YouTube channel?
YouTube channel is just youtube.com/ERCOST60. ERCOST60.
ERCOST60. Okay, thanks.
Last time you guys played with a Hot Wheels track. That's what I do.
You do Hot Wheels, cool.
Yeah.
We saw the installation. They had an installation at
the museum downtown?
Yes.
Yeah.
On the Alamo.
It's not, yeah. It's,
remember the
Metropolis 2, yeah.
Metropolis?
Actually, it's nothing to do with Hot Wheels.
No.
But we had to go see it. It's too cool.
Where is it?
It's at the LACMA, right? LA County Museum of Art.
It's a room of like a city with tracks, and they release about 1,000 cars.
Oh, awesome! How fun is that?
There's always hundreds of cars rolling around. It's like noisy from the noise of all the wheels rolling around. Yeah, so that's the end. It drops one.
Yay! I win! It's clapping.
Yeah. Using that little board.
Release one. So this is, you see, this is going 0101001. This is going 0011 0011, and this is going slower and slower. And the cool thing about this is the actual program decodes a lot of this stuff for you. There's SPI bus, there's I2C, there's CAN bus like in your car, all these different things, and all you do is you tell it what protocol you're using and what pins. And like right here, you can see this is the data, and down below it says this data is actually that value. And the first one is it's saying I'm going to write, and the next one says I'm writing this value. And you can just you can scroll. I must be sitting down. It works better. You can just scroll through this data. You can zoom in and out, etc. And if people want to actually take a look close up and do it, because in a big crowd, if I had a big screen, I could go through a lot of stuff, but if I sit in front of this, I'm going to block out the view. But it'll also tell you if there's, on any of the buses it recognizes, it'll tell you if there's a violation, if there's a problem, if a command was denied, etc. A lot of times you'll be programming like the little Wi-Fi